Okay, when a non-polar dielectric material is placed in an external magnetic field, suppose we have a non-polar dielectric material. These are the atoms of this non-polar molecules are atoms of this non-polar dielectric material. Because the atoms have no dipole moment, and also the material has also no dipole moment. Here the external electric field is 0. Now once I place this non-polar dielectric material in an external magnetic field, like if I apply an external electric field E, I call it E naught. This is the external electric field. Then these are the atoms or molecules, whether they are atoms or they are molecules. And we know that when an atom or molecule is placed in an external magnetic electric field, then positively charged nucleus shifted in one way and negatively charged electron cloud is shifted towards the other way. So we have a net separation of positive and negative charge. So these are, let's suppose this is an atom or molecule which is neutral, but once we placed it in the external electric field here, then the positive charge shifted in one way and negatively charged are shifted in the other way. So we have a separation of positive and negatively charged. So by this separation, the atoms also elongated, and also the negatively and positively charged, they are separated. Negative, positive, negative, positive, negative and positive. So here the direction of electric field is internal electric field. This is the external electric field. Its direction is this one. While this atom has a net electric field because the positive and negatively charged are separated, which is this one. This is a net, this one. This is a net electric field, 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 this one. So overall there is an internal electric field induced due to separation of positive and negatively charged of molecule or atom. This is internal electric field. I will stop this discussion of non-polar dielectric material here. Next I will come to the topic of like when a polar dielectric material in an external electric field. As we know that a polar dielectric material is that material in which the individual atoms have a dipole moment, but the net dipole moment of the material is 0. Like we have, I consider only 3 or 4 atoms, okay? I'll consider only 3 or 4 atoms. This is, let's suppose this is negative, this is positive. Let's suppose this is negative, this is positive. Let's suppose this is negative, this is positive. Let's suppose this is positive, this is negative. Now here the dipole moment direction is this one. Here the direction is this one. Here the direction is this one. Here the direction is this one. If I add all these 4 vectors, we get a net dipole moment which is 0, or the net electric field inside the material is 0. Like here, this is the external electric field is 0. So this is atoms or molecules has a net dipole moment, but the net dipole moment of the material is 0. Now we know that when a dipole is placed in an external electric field, suppose we have positive charge plus q and minus q, which are separated by a distance d. Once we placed in an external electric field, what will happen? This is negative side, this is positive side. So there is a force on this positive charge in this way, there is a force on this negative charge on this way. So it means that this is a couple. So due to this coupling, a torque is produced, and that torque rotate this dipole in such a way that this dipole align itself in the direction of electric field. This is an electric field. So this is now positive Q and this is now minus Q. So there is a torque. Similarly, if we place this material, this polar dielectric material, in an external electric field E naught, then what would happen? Originally the dipole moment of each individual atoms, they are oriented in different directions. Now they rotate in such a way that each dipole of each individual molecules or atoms align itself in the direction of electric field. So we have a situation like this now. So this atom will move in this way, this atom will move in this way, this atom will move in this way, this atom will move in this way. So there is a rotation of the dipole moment from this direction to this direction. There is a rotation of the dipole moment from this direction to this one. There is a rotation from this direction to this one, and there is also a rotation from this to this one. So this is the external electric field E naught. Now there is an internal electric field induced inside this material because the positive and negatively charged, they are separated from each other. So there is an internal electric field E prime also induced in this material. So from this discussion we conclude that whether the material is polar or non-polar, whatever the case, once we place it in an external electric field E naught, then the positive and there is induced electric field appear inside this material such that the direction of this induced electric field is opposite to the direction of external magnetic electric field. So you have to remember this concept. Now come to the case of dielectric and capacitor now. Dielectric and capacitor. Suppose we have a capacitor consists of positive and negative two plates. One is connected to the positive terminal and one is connected to a negative. This is positive, this is negative. So there is an external electric field between the plates. This is the direction of electric field. Now suppose we insert a dielectric material here. Whether the dielectric material is polar or non-polar, I am not going into the detail of that again. So once we place this dielectric material here, what will happen? This is the dielectric material. I consider the non-polar case. Just 4 atoms, okay? Once I applied an external electric field, I place this dielectric material here. What will happen? Again we have 4 atoms, okay? The atoms get elongated, positive and negative charge separated from each other. Now this is positive, this is negative, this is negative, this is positive, this is negative, this is positive, this is negative, this is positive. So what will happen? If I consider only 4 atoms, then this positive charge cancel this negative charge. This positive charge cancel this negative charge. If I have, let's suppose, an array of 3 atoms, then this is negative, positive, negative, positive, negative, positive. This positive, this negative cancel each other. This positive, this negative cancel each other. So in between there is no net positive charge. So the positive charge is here on the edges. The negative charge is on this side and the positive charge on this side. So overall this material looks like this one. So negative charge appear here and positive charge appear here. So the charges are separated. In between we have negative and positive charges, but they cancel the effect of each other. So here this negative charge and this positive charge, they are separated. So there is an internal electric field E prime, and we have external electric field which is given here. So we can say that once we place this dielectric material inside this capacitor, then the polarization, this process is called polarization of atoms. Polarization occur due to that polarization. Positive charges appear on the left right surface of this dielectric, and negative charge appear on the left surface of these charges. Due to separation of positive and negative charge, an internal electric field is developed inside this material, such that the direction of internal electric field is opposite to the direction of external electric field. Now the internal electric field is smaller, the external field is greater. So if I plot it like this, I will use the proper capacitor now. So we have capacitor plates. Here we have positively charged plate. Here we have negatively charged plate. This is connected to the positive terminal, this is to the negative terminal. And once we place a dielectric material here, the external electric field is this one. This is E naught, which is due to these plates. While the internal, there is a separation of charges. Positive charge appear here, negative charge appear here. So here we have a internal electric field E prime. So the net electric field inside this material, now this field minus this one, net electric field is now E naught minus E prime, because they are opposite in direction, so their sum will be this one. So the net electric field is this E, which is smaller than this electric field. Now E is smaller than E prime. E prime is the field when no dielectric is placed. Dielectric is placed. And E is the field with dielectric. So the field with dielectric is less than the field without dielectric. That's the reason we say that the electric field is reduced by a factor Ke. So the electric field inside these plates is now reduced by this amount, from E prime to E by this amount. No, sorry, from E naught to E by this amount. Now electric field is reduced here. Now the electric field is reduced by inserting a dielectric material in between the plates. Now we know that E is decreasing by introducing dielectric material. Once E is reducing, then from this relation V is equal to ED, this V also reduced. If V is reducing, then from this relation Q is equal to CV. Q is constant on these plates, so it means that capacitance is increasing. So it means that with same potential, if there are, let's suppose, how many charges? 1, 2, 3, 4, 5. 5 charges without dielectric, then once inserting the dielectric, we can store 5 more. So the charges increase by a factor Ke, electric field decrease by a factor Ke, potential is decreased by a factor Ke. This is the concept behind the dielectric materials, that why inserting a dielectric material, the capacitance of a capacitor increases. The reason behind this is the reduction of electric field. The electric field reduce from this to this one. Once E is reducing, then V will also reduce by using this relation. Once E is reducing, then capacitance of the capacitor will increases by using this relation. Thank you.